So first, we will see what is the gyroscopic effect. Then we have to do a derivation of a formula which will let us calculate what is the gyroscopic couple. What is the value of gyroscopic couple? After doing this derivation, next we can go ahead and solve some problems. Fine. Now in the problem, apart from the value of gyroscopic couple, we will also have to predict in what direction the couple will act. So we have to know how to detect the direction of couple. So there are various different methods in which we can predict what is the direction in which this couple will act. Fine. So we will see one or two of the methods, and you can conveniently use whichever is suitable for you. Okay. So first, derivation. Will we do? Okay. So before going to derivation, we should understand what is this gyroscopic effect. Why does it come into effect? Fine. You already know about another similar force, that is inertia. What is inertia? It is a force which acts whenever an object accelerates. Whenever an object accelerates. Fine. So, suppose you are sitting in a bus, suddenly the bus starts moving. What happens?
We get a backward jump.
We get a backward jump. So, our body wants to stay at rest. Our body wants to stay at rest. But the bus is moving. But we want to stay like, no, I want to be stationary. The bus will carry me. Then suddenly the bus is moving very fast. Suddenly a brake is applied. So your body wants to continue moving with the same velocity. But the bus has stopped. So inside the bus you move forward. Right. So this is inertia. Now inertia is very easy to understand, because inertia force is equal to mass equal acceleration. Just this negative sign will define its direction. Fine. Bus is stationary, suddenly it starts moving. What is the direction of acceleration?
Negative.
Acceleration is forward, backward.
It is
Acceleration is
forward.
forward. Bus is accelerating in forward direction. So you will experience a force which is
Backward direction.
that is why it is negative sign. Fine. The bus is moving fast. Brakes are applied. What is the direction of acceleration? Backwards. It is slowing down. Velocity is decreasing. So acceleration is
Backward.
actually it is deceleration. Reduction in velocity. That means acceleration is
Backward.
backwards. Fine. So the force you are experiencing is
Forward.
forwards. So it is always opposite to the direction of
Acceleration.
acceleration. So predicting direction in case of inertia force is very easy. Fine. But predicting the direction in case of gyroscopic is a little tough. Fine. So inertia is the effect we come across in linear motion. Inertia is the effect we come across in linear motion. So some similar effect will come into effect when we take up rotational or rotary motion. So that effect, the motion in case of rotary motion, the effect in case of rotary motion is gyroscopic effect. Fine. Now let us see how this gyroscopic effect will act. So first we will have to derive the formula. Fine. After deriving formula, we have to again predict direction. In this case, it was opposite to acceleration, easy. But in gyroscopic, it will be a little tough. We will have to see how it is. So should we start? Okay. So inertia is F m into A. Now linear F equal to m into A. So rotary, you have to convert the same equation into rotational equation. Fine. So instead of force, we have to take
Torque.
fine. this torque we generally call it as CG. C means couple. C means couple. G means we represent this torque as CG. CG means gyroscopic couple. Now instead of M we have to take M is mass. Mass in the linear is equivalent to what in rotational? In the first class itself I have told you. Mass moment of inertia. Mass moment of inertia. So whenever you have M in linear equation, the same equation in rotational, you have to replace M with mass. Then acceleration. This is linear acceleration. This should be converted to alpha. So this becomes the equation. Fine. Now I for any object it is constant. So we have to find alpha. Alpha is scalar vector. Alpha is scalar or vector? What is alpha? Angular acceleration. Alpha is angular acceleration. Its unit? Radius per second square. So if a disk, as you will see later, suppose the velocity, angular velocity is in this direction, and this angular velocity is increasing. This angular velocity is increasing. So alpha will be in this direction. Now what is the direction of this alpha? What is the direction of omega? Omega is rotating like this. What is the direction of omega? Anti-clockwise. When seen from this direction. From that direction, clockwise. I want a fixed one. When I say a direction, it should not change when I change my position. Unambiguous. Fine. How to define direction of this omega? We use something called as right hand rule. We use something called as right hand rule. So right hand, in whatever direction my fingers are rolling, if this is the direction of the rotation of disk, then my thumb will give me direction of angular velocity or angular acceleration. Fine. Now omega is rotating like this. So my fingers are rotating in the same direction. So direction of omega is forwards. Now this angular velocity is increasing. Because it is increasing, this alpha is in this direction. Once again, what is the direction of alpha? Keep your fingers in the direction. Thumb will give us the direction of fine. Here single arrow, here double arrow. Why I am doing that? Because this is just velocity. This is differentiation of velocity. That's why double arrow. Got it? So acceleration is also in this direction. Fine. Now alpha is a vector. Alpha is a vector. And vector has two parts. First part is
magnitude and direction.
First part is magnitude. And the second part is direction. Fine. Now suppose I take this, I keep its angular velocity the same, and I change its direction. Does that mean the velocity is same or different? Direction I am changing. The speed is same. So the velocity, the angular velocity, is it same or it has changed? Magnitude is same. Direction has changed. So that means as the velocity changed, yes. That is what the bother with vectors. We think vectors are same as scalars. No, vectors are more complicated. For vectors we have to use geometry. We cannot use simple addition subtraction for vectors. Fine. So even if the magnitude is same, but direction is changing, that means there is a change in. If the velocity is changing, there will be some angular acceleration. Correct? So we have to find that change in angular acceleration. We have to find that change in angular acceleration. Now we have to find that in two steps. We have to find that in two steps. Fine. So case 1. In this case, we will keep its direction same and we will change the angular velocity. Okay, we will keep the direction same, but we will change the angular velocity. So this will be a simple case. So let us take it this. Okay, so initially its angular velocity is omega 1. After time, let us say dt, its angular velocity is changing to omega 3. Let us say initially it's omega. After some time it is changing to omega plus d omega. Okay, so let us draw it. Suppose direction is like this. Then again, this is the direction of angular velocity. Right? The initial length is omega. After some time, this length will increase by how much?
Omega plus d omega.
Omega plus d omega. So from here, omega plus d omega. So from here to here, that is the final velocity. So let us say O, A, B. Fine. So initial velocity. What is initial velocity? O, A. That is nothing but omega. Then final velocity. What is that? O, B. That is nothing but
Omega plus d.
Now both these final velocity, initial velocity, their direction is same. Their direction is same. So whenever the direction is same, we can use addition subtraction directly. We can use addition subtraction. If the direction changes, then it becomes more complicated. Fine. So now in this case, the direction is same, so we can directly use. So what is the change in velocity?
Final velocity minus
Change in velocity. Final velocity. What is final velocity?
omega plus d omega.
OB minus OB. Now because the direction is same, that's why we can directly use subtraction. Fine. So OB
Omega
omega plus
minus omega.
minus OA.
Omega.
Now open the brackets. Omega will cancel now.
D omega.
We are left with d omega. Fine. Now what is angular acceleration? Angular acceleration alpha. It is nothing but change in velocity by
Changing time.
time. Change in velocity by time taken for change. So change in velocity by time taken for change. What is the change in velocity?
D omega.
D omega.
By time.
And in what time it is changing? dt. So that is the angular
Acceleration.
Fine. This is the angular acceleration. In which case?
Direction is same.
Direction is same. So case 1, direction is same. Omega is changing. Okay. Now let's go for case 2. Case 2 is more complicated. Okay. Case 2. In this case,
Direction is different.
direction will change. Omega will remain same. Direction changes. And omega remains the same. Okay. Let's again take like this. It's rotating with angular velocity
Omega.
omega. Initially its direction is like this. Initially its direction is like this. After some time, let us say its direction has changed. It has rotated a little. Then they change the direction to take this. The length will be same because angular velocity is same. So the length will be same. Direction has changed. So let us say the angle is small angle d
Theta.
theta. Time taken for this change is again dt. Now again we have to find alpha. Fine. The magnitude is same, but the direction has
Changed.
I told you vector, magnitude and direction. Even if the magnitude is same, direction changes, there is a change in velocity. And if there is a change in velocity, there will be acceleration. Fine. So that acceleration change we have to find. So now, how to begin? This angle is very, very small. If this angle is very, very small, we can consider this as a right angle triangle. We can consider this as a right angle triangle. This is O, this is A, this is B. Once again, initial velocity. What is initial velocity? O, A. That is omega. But this is changing in direction. So better write an arrow above this. Fine. So whenever you have an arrow, that means we cannot use direct subtraction or direct addition. You have to be very careful. Fine. So this next final velocity to OB. Again put arrow. This value is again omega. Value is same omega, but direction is different. So that's why I put the direction. Okay. Now in this case, once again we have to find the change in axis. So the change will be this.
BA.
Change in velocity will be AB. Fine. So AB is the change in velocity. AB is the
Change in velocity.
change in velocity. Fine. AB is the change in velocity. So AB vector will be equal to final velocity
OB vector.
OB vector minus initial velocity OA vector. So now AB is OB minus OA. Now this is vector. You cannot do it directly. Fine. So in order to find this, we have to actually find the magnitude and direction of this AB. Fine. What is the magnitude of AB? Magnitude of AB. What is it?
Omega.
It's equal to AB length. Now to find AB length, you have to use trigonometry. This is hypotenuse. This is angle. This is matrix. Fine. So which ratio should we take?
Sine.
We need opposite. And we know hypotenuse.
Sine
So
theta.
sine theta. So sine of what is the angle?
D theta.
D theta equals opposite. What is opposite?
AB by
AB
OB.
by OB. So okay, now AB equals OB into sine theta. What is OB? Omega. And d theta is very, very small. D theta is very, very small. So what is sine d theta?
Sine theta.
When angle is very, very small, sine of that angle can be written as only the angle.
D theta.
Fine. That angle should be in radians. Don't take it in degrees. That angle should be in radians. Yes. Whenever the angle is very, very small, below 10 degrees or 15 degrees, we can directly take it as it is. It should be equal to the angle itself. There will be very, very small difference. Okay, there will be very, very
Small
difference. That's why we take it as d theta itself. Now, AB equal to omega
D theta.
Okay, what is AB? AB is Magnitude of AB. What is AB again? That is change in velocity. So we got the magnitude of change in velocity. We got the magnitude of change in velocity. So this magnitude will be used to find acceleration. What is acceleration? Same formula. Change in velocity by time. So what is change in velocity?
Omega
By time. AB is
omega d.
by time
dt.
dt. So this is the angular acceleration. This is the angular acceleration. This is the magnitude again. This is the magnitude. What about direction? What is the direction?
Minus.
Direction is from A to B. Direction is from A to B, and it is perpendicular to the initial velocity. Perpendicular to the initial velocity. Perpendicular to the initial velocity. Okay. So this is the formula. Now these two values we can use to find the gyroscopic couple. Fine. So now, now we want to find the gyroscopic couple. So gyroscopic couple we are writing as CG. Formula I. Fine. So so what is I we can find using mk square. If radius of gyration is given and mass is given, mk square equals the mass moment of inertia, and alpha we have to use this. Fine. Now, whenever we are finding gyroscopic effect, most of the times, the speed of rotor, the speed of rotating parts will be constant. Speed of rotating parts will be constant. So when the speed of rotating parts is constant, what happens to d omega? Omega is constant. Differentiation of constant? 0. Fine. Differentiation of constant? 0. So this acceleration we don't have to do. Fine. Whenever omega is constant, omega magnitude is constant. Magnitude is constant. So what happens? D omega by dt will be equal to 0. Fine. So alpha will be only equal to that second case. Alpha will only be equal to the second case. The second case is
Omega d theta by
omega d theta by dt. Omega is constant. D theta is the angle, change in angle. Dt is the time taken for change in angle. So alpha will be equal to this. The same figure. So CG becomes I omega by dt. Now, what is d theta by dt? Rate of change of angle of axis. Angle of axis. So this is again an angular velocity. This is again an angular velocity. But angular velocity for axis. Angular velocity for axis. G theta by dt is angular velocity on axis or rotational axis. Rotation axis. So this we will write it as omega p. This we will write it as omega p. By p, p means angular velocity of precession. Angular velocity of precession. So this is a very important formula. Okay. is a very important formula. The same formula we have to use on aeroplanes, ships, on two-wheelers and four-wheelers. Right? The same we have to use on two-wheelers, four-wheelers, everything. Okay. So this is giving us the magnitude. This is giving us magnitude. Then coming to the direction is a little complicated. I'll tell you after we will copy this down.